When we're finding confidence intervals for the population mean here, we want to start by understanding the formula. The formula tells me that the final confidence interval is going to take x bar minus the margin of error, comma, x bar plus the margin of error. We're going to need to calculate that margin of error using the formula z alpha over 2 times s divided by the root of n. So for each of these, I'm going to start by calculating the margin of error. Then I'm going to use the margin of error to create my confidence interval. Here, the margin of error starts with a z alpha over 2. This is the most confusing part of the formula when you first see it, but really you just need to memorize the three common ones. The z alpha over 2 here, since it's for a confidence of 0.99, z alpha over 2 equals 2.575. Here, since there's going to be a confidence of 90, z alpha over 2 equals 1.645. Here, since there's a confidence of 0.95, z alpha over 2 equals 1.96. These are the only three ways I'm going to give it to you on questions on tests, final, what have you. So these are the only three that you need to memorize for confidence intervals or have in your notes. 99% 2.575, 90% 1.645, 95% 1.96. So we got the z alpha over 2 out of the way. Next thing looks easy, but it's not necessarily. This says s. In Cengage, they tend to give you s squared. So we can't put this directly into the formula. We need to take the square root first. The square root of 100 gives me 10. The square root of 6.25 gives me 2.5. And the square root of 0.64 gives me 0.8. As always, use your calculator for those. Just put it under the square root to get those answers. I think I've got everything I need now to calculate margins of error. So for part A, the margin of error is going to be calculated as 2.575 times s, which is 10, divided by the root of n, which is 60. If I put that into my calculator, 2.575 parentheses 10 divided by the root of 60, I get an answer of 3.3243. 3.324, I'm going to call it. Go by whatever they say as far as number of decimals to round to. I'm going to 3 for whatever reason here, basically because this went to 3, but honestly, as long as you round according to their directions, I'm not that concerned about rounding. So now that I know how far I want to move in each direction, what a confidence interval basically says is we're going to start at the middle or whatever our average was from our sample. We're going to move this far in each direction from our sample so that under the normal distribution, we have 95% of what the values would be if our mean was the true mean. So here, I'm going to take the mean that we found from the sample 42, and I'm going to subtract the margin of error, 3.324. Then I'm going to take the same 42, and I'm going to add 3.324. When I do this in my calculator, 42 minus 3.324 gives me 38.676. 42 plus 3.324 gives me 45.324. So this is the correct confidence interval for part A. If I was asked to interpret it, then in repeated samples, 99% of the intervals created in this way would contain the true population mean. So basically, if we kept going and finding 60 people, if you will, found their average, used this formula to create a confidence interval, if we did that 100 times, we'd expect 99 of the times to include the actual true population mean. Part B. Again, we start out by calculating the margin of error. The margin of error is 1.645 times 2.5 over the root of 120. When I put this into my calculator, 1.645 parentheses 2.5 divided by the root of 120 and parentheses gets me to 0.375. So now that I have that 0.375, I need to move off the given mean of 150. So I'm going to start by doing 150 minus 0.375 and then 150 plus 0.375. Note that the minus always comes first because this is supposed to be read as an interval, starting at this point on the left, going to this point on the right. If you were to switch these, that would not be correct. You cannot start at a larger number and go towards a smaller number. So when I do 150 minus 0.375, it gives me 149.625. When I add it, I get 150.375. In this case, we're 90% sure the true population mean lies between 149.625 and 150.375. If we were to do repeated sampling like this, 90% of the intervals created would contain the true population mean. For part C, we start out doing our margin of error formula. Margin of error is 1.96 times 0.8 divided by the root of 75. When I put this into my calculator, 1.96 parentheses 0.8 divided by second root 75 and parentheses, I get 0.181. I'm then going to use the given mean of 3 to do 3 minus 0.181 and 3 plus 0.181. When I do 3 minus 0.181, I get 2.819. When I do 3 plus, I get 3.181. So, what that means is, I am now 95% sure that in repeating sampling, I would get the true population mean within the interval 95% of the time. So in 100 samples done this way, 95 of those 100 would contain the true population mean within their interval.